Okay, so a very smart calculus student looking at this kind of question will just say, oh, this is exactly equal to 0 because this right here is an odd function and you're integrating it over a symmetric interval. Well, that is only true if this function is defined on this interval. That is, if this function is defined from -1 to 1, alright? But this function is not defined on that interval because there is a point 0 in which this function here has a vertical asymptote. So in fact, this right here is called an improper integral of the first kind. Okay, so when we have an improper integral, this is how we handle it. We go ahead by splitting this into sum of two integrals, not really different things, but just based on the intervals. And we are looking at this from -1 to 0, and then we are looking at this from 0 to +1, all right? And that is it. So let me just put the function down here, 1 over x dx. Okay, we add it with, we put again 1 over x dx. So as you can notice, I have some spaces here. There is something I really want to do. But this is just from classical calculus that you can split it into two like this. Okay, that's nice. But we really want to take away this point 0. I know integrating over an interval like this, we can equally say, okay, this 0 may or may not be a member of that. But we want to look at this where we say, okay, let's approach 0 from the left concerning on this interval here, and on this interval we want to look at, let's approach 0 from the right, trying to exclude the point 0 to see what the result will give us. And that would be by, let's say we change this to some b, right, where this b is approaching 0 from the left, and we call that the limit, right, as b approaches 0 from the left of that. So this is where the b is, and then here we can still call it a b where b approaches 0 from the right, and we look at the limit as b approaches 0 from the right, and that is really nice. Okay, so when we split the integral into two like this, what we really want to look at is if each of them will be finite. So if we take the limit of this integral and it gives us a finite number, that is a real number, and we also take the limit of this other integral and we also get a real number, the sum of those two real numbers will give us the result of this. Okay, but if one of these is infinite, that is maybe this one is infinity or negative infinity after evaluating the limit, or maybe this one also. So if any of these gives us an infinite number, then we easily conclude that this right here diverges. Okay, that is, it doesn't exist or it doesn't converge, so it diverges, right? Okay, so that's how we're going to look at it. So in fact, it is enough to just test for one of them. If we test for this one and it gives us a finite number, that's when we can go test for this one, hoping it will also give us a finite number, so that we can just add the two finite numbers together and equate it to this. But if any of this is infinite, then we easily conclude that this right here diverges. So that's what we want to look at right now. So let's see what we have from here. So in fact, this right here is going to become the limit, as let's say b tends to 0 from the left, of this integral. Well, if you integrate this, okay, the 1 over x, the integral of that will just give us natural logarithm of, we ensure we have a positive input here, the absolute value of x, and we are taking that from -1 to b. Okay, that's nice. Now let's see what we have. Well, this right here will become the limit as b approaches 0 from the left of, we are going to substitute the bounds. Here we are going to have the natural logarithm of the absolute value of b minus the natural logarithm of the absolute value of -1. Okay, that's nice. Let's see what we have. Well, you know, this is a limit of the difference. We can take it as the difference of the limit. But this right here is just a constant. It doesn't depend on the limit. So in fact, that's it. And this is not just a constant. It is exactly equal to 0. Look at this. Now, the absolute value of -1 will give us a +1. That is just from the absolute value definition. Natural logarithm of 1, of course, is going to be 0. So everything here is 0. So we only have this one to worry about. So I'm going to take this as a limit. Okay, as b tends to 0 from the left. So if b is approaching 0 from the left, what we are really looking at is very small negative numbers, right? So if you have this, a real line, this is 0. Approaching 0 from the left is here. So you are approaching 0. So we can look at this as very small negative numbers. If you take the absolute value of that, it will become very small positive numbers. So we'll be approaching 0 from the right. So that is what I'm saying here. So we want to look at b as the limit as b approaches 0 from the right of the natural logarithm of, this time I'm not going to put the absolute values again because I have converted it, right? This negative input, I'm going to put the negative of b, and the absolute value can ensure that when we change it to positive, right? And that's what we have. And since this right here is 0, I will not worry about it anymore. So let's just see what we have. Well, as b approaches 0 from the left, what will the natural logarithm of b be approaching? So we would like to look at the graph of the natural logarithm function and see, as our input gets closer and closer to 0, where is the result heading to? Alright, given that this right here is a continuous function, we know that already. Anyway, so let's see what we have. Well, as we are approaching 0, this is 0 on the x-axis, okay? So the natural logarithm function will be approaching negative infinity down. So we'll go like that. We will never meet this line. In other words, the 0 cannot be an input, but we'll be approaching 0, negative infinity, okay, down. That means as we approach 0 from the right, okay, the natural logarithm of that input approaches negative infinity, and this right here is an infinite number. It is not a finite number, it is an infinite number. That tells us that this integral here diverges. So it is not equal to 0, rather it diverges. Okay, so you can really say this right here, or when I say this right here, I mean the whole of this, right, diverges. So yeah, so that is it. Anyway, that's great, isn't it? Okay, thanks for watching, and please subscribe to my channel, and I'll see you in the next video.